Thank you, Madam Toastmaster. Fellow Toastmasters, honored guests, everybody asks that question. What do you do? And I have a hard time answering it. My first answer would be, I'm a chemist. And everybody says, oh, you must be smart. I'm not so sure about that, but that seems to be the standard reaction. The older I get, the less confident of that I am. Maybe I'll say something, go a step further and say I'm an environmental chemist. That confuses the daylights out of everybody because they have no idea what that means. But the reality is I work in an environmental testing laboratory. What we do is test samples of soil, water, whatever, for pollutants. If you watch NCIS, how many people watch NCIS? The most popular show on television. You see Abby in the lab working with her mass spectrometer. She puts something into the mass spectrometer and poof, it tells her exactly what it is. It doesn't work that way. What we do is, we don't say, what is it? We say, are these specific chemicals present? We have a list of what we call target chemicals. Some people, well, the old name was the priority pollutants. Things that have been released into the environment that people care about. So if I put something into a mass spectrometer, it's not going to say, I'm not saying, what is it? I'm saying, okay, mass spectrometer, here are 50 chemicals that we're interested in. Show me exactly what these 50 chemicals look like. Okay, I know what these 50 chemicals look like. Here's our unknown from the field. Let's see if we match up with any of those 50 chemicals. So I may look for chloroform. Everybody's heard of chloroform. It's in your drinking water most of the time, small amounts.
Very nice.
Well, it's a byproduct of the disinfection process. In order to remove bacteria that could cause you a whole lot more harm, water is chlorinated, and that chlorine reacts with the bacteria or whatever else is in the water, and one of the byproducts is a small amount of chloroform. If I was testing drinking water, which I've done over the years, one of the things we do is measure how much chloroform is in there. There is a specific limit on how much can be in there, roughly 50 parts per billion, and if there's more than that, there's concern, but there rarely is. And that's something that the water treatment folks keep close tabs on. I personally, day in, day out, the things that I look for are pesticides and PCBs in soil, which, if you think about it, sounds like a strange combination. Pesticides, like DDT, everybody's heard of DDT. It was sprayed everywhere for many, many years until it was banned in the 70s. And it still shows up in, I see it just about every day because it sticks around, a persistent pollutant. And we measure it. Again, the way we do it is we have our instrument, we shoot in some DDT, we say, okay, it gives us a peak in 8 minutes. 8 minutes after we inject it, there's a peak. We put in our sample, our unknown, soil from, oh, that came from an insecticide plant? Okay. Here's a surprise. We got a peak after 8 minutes. I bet there's DDT in that soil. And the size of the peak tells us how much DDT there is. PCBs are another one of the chemicals that I look at. Some of you will remember way back when every street had telephone poles all up and down the street. On the top of each pole was a big box of something that did something electrical up there, and up until the 70s those things were filled with PCBs. Why were they filled with PCBs? Because they did the electrical things that needed to be done, and because they were considered a very safe chemical that did that. Turns out one of the nice things about PCBs is they don't burn. That's one of the reasons that they're up there. However, they will burn if you get a direct hit with lightning, and what happens when it burns is it puts out some stuff that's rather nasty. Now, so pesticides, insecticides, and PCBs, almost nothing in common except for the fact that they're chemically similar and they show up on the same instrument fairly well. That's why I test them both, because that's the instrument I work with. Another reason that we look for these things, often in samples where you would not expect them to be, is because we have this priority pollutant list where if somebody wants to dispose of an industrial type waste, they're required to look for a whole list of things that include the things I look at before they can dispose of it. For example, one of the things we dealt with is sites of airplane crashes, where the thing you would normally look for would be jet fuel, and that would make sense. And we do look for that, but we also look for pesticides, not because we would expect the airplane to have been carrying pesticides, but because if the pesticides happen to be present in this farmland where the plane crashed, then that changes the rules on how you dispose of the soil that might be contaminated with the jet fuel. So that's basically what I do. Those are the things I look for. How do I look for them? Mostly sitting in front of a computer and looking at those peaks that come out of the instrument and measuring them and turning that into a report. I'm Toastmaster.